And welcome to Code or Not to Code. I'm Neely Eva, and as always, I'm very happy to be here today. And I'm here with my very good friend, Stefan. How are you doing, Stefan?
Splendid, because we are about to crack open what's new in .NET 9 and also C# 13, and I've been waiting all year for that.
All year? Awesome. That sounds great. If you're new to this show, the two of us meet every other week and work on our .NET tool. And we have as Stefan said, a very, very exciting stream ahead of us. But before we dive in, please take a second to follow us on any of your preferred social medias just to keep up to date with our upcoming streams, because we're about to head into our Christmas break and you wouldn't want to miss our next and upcoming streams. And also, obviously, if you have any questions or comments, you can reach out to us there. All right. Hello, Eric. Welcome to the show. So I guess we can dive right in. As Stefan said, we want to have a look at the new features in C# 13 and .NET 9. But I've got to be honest, Stefan, this year, I'm actually going in a little blind because last year we had this newsflash section in our stream. So every other week we would actually talk about all the updates and the things that are sort of changing. And that kind of kept me in the loop a little bit. And since we stopped doing that, I also stopped looking into it a little bit. So yeah, I'm very glad that we've got some help today with those new features. Because none other than Stuart Lang is joining us in the stream today. We've met him last year if you're a regular of the stream. Stuart is a principal engineer at JustEatTakeaway.com and a Microsoft MVP, and just overall an awesome human being in the tech space with loads of community events and open source contributions. So please welcome Stuart.
Hey everyone. Yeah, thanks for having me. Yeah, love to. Pretty happy to be on the show. Yeah, how's it going?
Good. Thanks for coming back. We're really, really happy to have you back.
And apologies for last week or 2 weeks ago. The internet providers let me down. So yeah, sorry about that.
Absolutely no worries. Last time was a little bit, you had technical difficulties. We had technical difficulties. We still had fun on the stream though. Sometimes you need those little hiccups to, keep it interesting, keep everyone on their toes, us on the toes, the viewers on the toes, the internet on its toes. But no, we made it work.
Cool. Shall we jump right into it?
Yes. Yeah. So let me share my screen. And yeah, what I thought we'd do is I'll just present quickly some of the new features coming in C# 13. And then we can talk a bit more about what's new in .NET 9 in general. And then we can jump into some code and try and put some of it into practice and see how it goes.
Sounds amazing.
Awesome. So let me share my screen. And hopefully,
woohoo!
Yay! Cool. So C# 13 .NET 9. As you mentioned on the last show, every November we get a new version of .NET, which is awesome. That's also when we get a new version of C# 13. It's always hard to remember the version numbers, but I think you mentioned the rule of 4, which is you just take .NET and add 4, and that will be easier when we get to 10, because I think I constantly say C# 9 and .NET 13, and it's all a mess. I do know what they all mean, honest. But yeah, for those who aren't familiar or not, don't do .NET day to day, just a reminder of how it all kind of works. Every November, as I said, we get a new version. This version, the odd version numbers, are what we call STS releases, or standard term support. Every release of .NET is is of the same quality. It's like a production, fully supported. It's all good. But the even numbers, 711, that's a good way of remembering it. The even numbers are long-term support releases. And what we like to say at work is we recommend that you upgrade to every version. However, if you're the sort of person or the sort of team that doesn't want to be forced into a 6-month window of having to upgrade your .NET version, then you're probably sort of people that would want to stay on the LTS releases. So for some folks, the LTS releases are a bit more casual. It's like you can see from the overlap of these gray bars, you've got like a full year to migrate, and you only have to upgrade every 2 years. or if you're crazy like us and we want to get on it as soon as it's out, every year it upgrades. But whenever it's an LTS release, just bear in mind the following year you've got a 6-month window you're committing to. So just remember you're committing yourself to that upgrade, because you don't want to be out of support with this stuff. So yes.
But the STSs, it's not like they are like preview or experimental or any of that. It's just the support window.
Yeah, it's just the length of the support window. It's all the same quality gate. They don't say, it's only an STS. We'll drop our quality bar. No, it's nothing like that. It's always good. So we mostly upgrade, but for some teams they're a little bit slow and easygoing, so we just let them do the LTS releases. But yeah, I know some companies just say LTS, and for unfounded reasons, you can't win them all. Yeah. So .NET 9 introduces C# 13. I'm going to go over some of the features of that, but just like an upfront admission, it's not the biggest release of C#. There's lots of features in .NET, but in C# specifically, C# 13, there's some very niche features. Some of the big features we're hoping for have unfortunately slipped, and so they'll be coming in a later release. I can touch on some of those things because some of them are really cool. But yeah, this is a smaller release, so it should be a short slide deck. Just to give you a taste of some of the little teeny improvements. This is one of the features, which is when you have a string, there are certain characters that you can sort of do / and these sort of escape characters, and they've introduced a new one. So for example, in this code here, we're doing console write line, and we're writing out some code, and I'll explain what this code does in a second. But whenever you want to do like what's called an escape sequence character, you usually have to do /U, which for Unicode, and then like 4 hex digits, and you usually go 001B, and you just have to know that means the escape sequence. And when you're writing to a terminal, that means you can like do things like switch colors and do cool stuff. They've just added a nice little, this is the smallest feature, so we'll start small. They've added this little /E that means the escape character. So now it's just nice and more succinct. What does this code do? If you've got a terminal that supports rendering images like iTerm2 on my computer, it will render like images. So I like to have little animated GIFs when I build CLIs. So that's what this code does. So you can do cool stuff in terminals with the escape sequence character. Now it's just a little bit more easier. So that's a very small and nice one. One I've been waiting for years is params collection. So just to explain what this feature is, today or prior to this feature in C#, you had the ability to have what's called a params array parameter. So if I put my pointer here, you see we have an integer of numbers here in this as a parameter method. But if we say params, what that allows you to do is at the call site, you can just say print numbers, and you can put nothing in there, or you can put one value or multiple values. And what will happen is the compiler will sort of under the hood will write the call site, write the code that says new array, and create the array for you. And one of the problems with this is we often don't want to just new up arrays unnecessarily. So for example, on this first line here, you actually new up an empty array, which is just really wasteful because that gets heap allocated and then you get garbage collection. So for performance reasons, generally in .NET, we try and steer away from this, which is a bit of a shame. What we've always wanted to be able to do is have different types that we could accept here. For example, IEnumerable, or more recently, read-only span or span, just so that we can have an input that doesn't allocate on the heap and is performant. So that's what we've always asked for. And it's always been a bit tricky because it's always been a bigger problem than it sounds like. Like it's, because part of the problem is, well, how do you create, because with an array, it's simple. You just new up an array. But how do you create like an IEnumerable? How do you create a span, a read-only span in a way that makes sense and is efficient under the hood? And it turns out that this problem was solved in C# 12 with collection expressions. So this new feature lets you now use params with any type. So here we have a read-only span, and it all just works in the same way in terms of the call site. But now we have a read-only span that's not allocating, and it just works as you would hope it would work. And similarly, for example, IEnumerable, we could do the same. So it just works. And the way that they've implemented this again is off the back of the work of collection expressions. So they solved in C# 12 how to do collection expressions. And so basically this is technically implemented the same way as if you'd written these as collection expressions in line. So the decision of, well, how do I construct an IEnumerable in a way that's efficient? Well, that's already been solved now. So they can just lean on that. And now that we can have these params expressions, and you can see here, I've screenshotted this from Ryder, and Ryder's suggesting, oh, you can elide the square braces. So yeah, it's just this is a really nice little one. If you have in your code places where you're doing params array, it's likely a nice little refactor you might want to do now.
And because I think last year we talked a lot about, I guess, the collection expressions, and wasn't there also like this builder attribute that we used with that? Can you use that here as well? Because you said it works pretty similarly.
Yes, I believe that's. I actually don't know, but I think so. So we can find this out, but let's try it out. I think
okay.
Yeah, because I think the spec says effectively you can do this for any collection that supports collection expressions. I think effectively this is just combining the two features. So let's see if we have because we did do that last time. I remember.
Yeah.
That was fun. It was some learning for me. So I think this will work, but we will see if it doesn't work.
Awesome.
And so another sort of, this one's a bit more of a rough edge that they've fixed. So this is a bit of a mouthful. So ref and unsafe in iterators and async methods. So a bit of a mouthful, but let's talk about what this feature is. So if we have a async method and we have an await in there and we have some code, an async method is a bit like an iterator method in C# in terms of the compiler needs to do some work with that when we compile it, and it turns it into a state machine. So an async method is basically kind of like a workflow that's resumable, and the compiler turns it into a state machine, which is the way it does that is by generating a class for this method and storing some state in that class in terms of the position, how far into this async method it is, but also any state in that method needs to be stored in that class now, because it's sort of the lowered code needs to be able to work the same as the code you wrote, right? So this code here, it may not look complicated, but the compiler generates a class for it effectively. And if we want to do things like use span of t, like in this case, it doesn't work. You can see I've got a compiler error here. I've got a little squiggly red line. And the reason for this is span of t is what we call a ref struct, and that's only allowed to be allocated on the stack. And so if we were to move this line to the top of the function here, top of the method, it would, apologies, no pun intended, but it would span over the await keyword. And so you can think of the way the compiler works with async methods. You can think of it as like cutting with some scissors, cutting the method where the await keyword is and splitting it up into individual blocks. If we were to move that line to the top, it would span over two of these blocks of code. And so it would need to store this span into a field in the generated class under the scenes. And that's not allowed, right? So we wouldn't be able to do that, right? But nothing stops us from, between the await keywords, and the same is true for iterator methods, between the yield keywords, nothing stops us really from being able to use stack allocated variables just within those blocks. So in this case, we're not doing anything above the await keyword. So why can't we just use this span that's stack allocated? Why can't we just do it? And simply put, in C# 13, they've fixed that. So if you compile the same code in C# 13, the warning goes away. There's still the constraint, of course, that if you move this, if you start using code, unsafe code or ref structs across these boundaries, it won't work because it can't work. But in these sort of localized sections of these methods, it's now allowed. And this is really nice because I think, initially in the early days of span of T, we weren't using them that much, but now we use it more and more. So I feel I run into this quite a bit. So this is actually quite nice. So yeah, before you have to kind of create a local function, do your, ref struct work in there, and then call it from here. So now it's just tidier. So yeah, nice little one.
Then the unsafe is that if I have an unsafe block,
yes,
that spans multiple awaits or multiple yields. No, it
it
didn't work. I guess so. It still doesn't work if I have an unsafe block that spans multiple awaits, but I can now have between await blocks and yield blocks, I can have an unsafe region now.
Yeah, exactly. They just loosen the rules between the await keywords and the yield keywords. Yeah.
Cool.
Now this is one I will use. I will use probably next year, but it's here today. I'll explain why. But so there's a new lock object in town. I'll explain how this works. So today, or historically, the way you do locking in C# is typically you create a new object and you then lock on the instance of that object. This is typically how we do it, right? And that could be like a static property, or maybe you have an instance. It depends what you're like, what level of isolation you're trying to create with a lock object. And you create this object and you're just using the reference of it as the kind of, I guess, like the key to the lock entry and the kind of gating of a block of code to create this exclusive access to some code. And it's just really odd because it's really strange that we just create this new object. We don't new up objects anywhere else in C#. We don't use the object keyword much. Like there's scenarios where you might use it, but in modern .NET you don't really use it. It's just a bit strange. And what happens under the hood when you do this is the compiler generates a load code that says like monitor dot, I want to say enter lock. I forget the exact method. Might just be enter. But it passes a reference of that object that you're locking on into it. And the .NET team have realized that it's actually more performant if you had a lock object that had the behavior baked into it, rather than going the other way around, having a static method be passed the reference to a thing. Anyway, let me show what the new one looks like, just to make it clear. So they've added in .NET 9 under system.threading, they've added this new lock implementation, and it implements a pattern that the compiler is now aware of. So it now returns like it returns a class with a enter scope method that returns I think a ref struct with the dispose method on it. Anyway, there's a pattern that the lock object implements that then lights this feature up. So if you do this now, you now create a lock object. So just from a sort of I guess aesthetic point of view, it now just reads clearer because I could give this lock object a bit more of a nicer name, but I can see immediately it's a lock, right? Before I was kind of guessing. When I saw object, I go, oh, object, that's probably a lock object, right? But now it's nice and clear. This is a lock object, and it can have specialized implementation. So here the lock implementation is slightly more performant. The numbers really aren't exciting. If you look at the benchmarks, it's just a bit more performant than the built-in previous lock. But what I think is more interesting is they could add different types of locks. So they could have like a spin lock, or they could have a semaphore lock. So in future versions of .NET, they can add different implementations that fit the same pattern. And you might pick them for different scenarios. But now we have like a kind of first class concept of how to lock on a dedicated lock object. So for me, it's more the aesthetics of it, but there's a performance benefit, and there are like abilities down the line to have different types of lock. So
now this is a pattern. Can I also use my own Stefan's lock type?
Yes, and I don't have. I was going to have a snippet with the shape in, but yes, you can have Stefan's lock. Yeah, it needs a enter scope method that returns a ref struct that has a dispose method on it. So it's like the dispose pattern. And yeah, you can do it. You can build it your own way. A reason I won't use it much is because I think locking and when I use the lock keyword, it's typically inside of library code. I don't have, when I'm building an application, I generally don't have these heavy locks around. It's usually in like low-level libraries, and low-level libraries I'm usually multi-targeting for .NET 8 as well. And if you do this with .NET 8, I'm trying to think what happens. I don't know. I don't, because like there's an opportunity for this to be identified as object rather than lock, and lock on the instance of this lock object with the old style. Now I think you get a compiler warning if that happens. This is me like remembering some of the detail on this, but I think you get a warning on that. But like, I would want the implementation to be the same on .NET 8 and .NET 9. And so people have attempted to polyfill it, but to polyfill it properly, there's a naive polyfill you could do, but to polyfill it properly, someone's actually built a library that does that, and it's actually really involved and really complex. You wouldn't have thought it, but there's like thread abort exceptions you have to handle in a specific way, and all this complexity that means that even if you polyfill it, it's not quite right. So anyway, for me, it's just a bit messy. So I'm for those scenarios, I'm holding off for when .NET 8 goes out and .NET 10 comes in. I'll then probably move to this. But yeah, it's a nice little feature. Again, these are all little.
What's polyfill?
Yeah, so polyfill libraries where so when Microsoft released new language versions, they've taken the stance of deliberately saying we will not make this work for older versions of .NET. So for example, if I'm targeting .NET 6, well, .NET 6 is out of support, but if I use one of the new language features, there's no guarantee it will work because they haven't made the effort to make it work. Now, the reality is it might just work. Like if the language feature is, if it's just a syntax thing, it might just be, hey, it just works, right? And there's lots of features like that. But some features rely on attributes that don't exist. So sometimes you just define the attributes and hey, it works. But sometimes they require types, and so polyfill libraries are libraries that just are designed to do one thing, and that's drop in and fill in the old runtime support. So like for .NET Framework and for .NET 6, or now I guess .NET 8, to add support for the new language features that come in C# 13. Okay. So yeah, I wrote
kind of like translating the new features to like old versions.
Yeah, exactly. Yeah, bringing the new features, language features back to old versions. And the idea is like, as a language, as a library author, I want to still support those older frameworks, but I want to use the new shiny stuff. So the idea is I drop it in, I use the new shiny, and everybody's happy. Is the idea?
Sure.
Partial properties. This is an example of like a syntactic one. Again, so this is one you wouldn't need to polyfill because all the implementation is just a language level. There's no like moving parts to it, for example. But yeah, so partial properties are what they sound like. But just to show an example of where they kind of shine, in .NET 7, I think they introduced the source generators for regular expressions. So you might have historically created a regular expression object that had a regular expression pattern in it. you might have done that inline, and then you do isMatch or whatever. And in .NET 7, they added the ability to have a source generator version of that, which is more performant. So you get a little a light bulb saying, "Hey, upgrade to use the new pattern," and that's nice, but it's ugly, right? Because you have to move it out into a method, and you have to put an attribute on it. And one day, maybe interceptors will fix this, but that's a story for another day. But what you would do if you were to sort of follow the Microsoft guidance is you'd say, okay, I'll create a partial static method that returns me the regular expression. I'd say, naming's hard, by the way. I'd say get my regex. Then this source generator here will generate the partial implementation for me, and then I can call it. I can call this match. Great. But the fact that it's a method is like just slightly annoying, because why is it a method? If you were to implement this yourself, you'd build it as a property. And that's because you can't have partial properties prior to C# 13. So they've just fixed that. So now you can say partial, regex and describe it as a property. And now it's a partial property. And they've updated the generator as well. So it will build that partial property. And it's just ever so slightly neater.
I love this so much more, because I was always wondering with the method, do I always get a new regex? How is this efficient?
Yeah.
Well, they do caching under the hood, but it wasn't.
It'll cache it.
Now I see it. I love it.
Yeah, it takes away that question. Yeah, you don't have to think, does it? You kind of would assume that that the getter will be just one instance. So yeah, it also is more clear. Overload resolution priority. This one, it doesn't sound very exciting, but honestly, this is with all these features, they don't sound very exciting, but they are. No, this one's a big deal in my mind. For me specifically. So to explain overload resolution and overload resolution priority, I'll give you an example of where they're using this and where it really shines. So in C#, when you have multiple methods of the same name with different parameters, this is called a parameter group. And when you dot into it in IntelliSense, debug.assert, there are multiple overloads of that. And when you put some code in there, when you compile that code, the compiler needs to decide which of these overloads are you saying that you want. So for example, if you have like an array of characters, is that a string or is that array of something? Those sorts of questions where there's ambiguity. The language specification needs to say exactly which one wins. And those rules are really complicated. And in fact, like there are languages out there that specifically do not do overload resolution specifically for this reason, because it gets complicated, it gets messy fast. It's actually a real performance headache. Like it's a hard problem to solve. And for the API, sort of the API review team who create APIs, often they're saying, damn it, we can't add this new API because the way that works with overload resolution means that these people have breaking code now that doesn't work. So it means that it's hard to evolve the language. So looking at the code on the screen and the example here, if we said debug assert 5 + 5 equals no, I can't read. 2 + 2 equals 5. There are two methods here. There's one that takes a bool and one that takes a bool and an optional string. And what would be kind of nice is if we could use the new feature that came 2 versions ago in C#, which was use the caller argument expression. Because wouldn't it be nice if you just said assert 2 + 2 equals 5, and then if the assertion failed, it would just say, it would capture this expression and say, this expression you're expecting to be true, but it's actually false. That would be kind of cool. However, if I click on that in Rider and highlight it, you see that it picks this one. It doesn't pick the one we want. And so this is one of those scenarios where it's like the language team was so close. They were like, damn it, we've introduced this new thing that's really nice. And this is the same, by the way, same problem for fluent assertions, for shouldly. We all want to use this caller argument expression feature, but we can't, because when you do it, you realize, I can't do this in a way that works with the existing APIs because overload resolution will just pick the wrong one, and I don't get the expression captured. This is just one example, but there's like a whole family of these scenarios where the language team or the API design team could never do the thing they wanted to do because overload resolution meant that the wrong one was picked. So what they've done is they've added, and this is an example of something you would polyfill. You need this attribute, right? They've added an overload resolution priority attribute, and it's a bit of a, I don't know, you look at it, you go, that introducing a priority ordering of this feels a bit clunky. I don't know, but it serves a really useful purpose because you can say, hey, downrank this overload and treat it as a lower priority than anything else. And so now we can now fix the resolution. So with this new feature, you can see in Rider, if I click it, it's picked the other flavor of it. So this is a way you can now steer where you think the overload resolution is wrong, you can kind of steer it to the right place. And we've added this in Shidley in a couple of places around, like, because sometimes you want assertions to match on specific, I think the example we have is like a specific dictionary type. But without this feature, you'd pick the wrong overload and you'd pick the wrong logic. So there's lots of places where you kind of want to be able to get in there and say, do not pick this one, pick this one last. And you can have multiple of the attributes and have them all compete with each other and change the rankings and stuff.
Why is that set to -1 and not +1 on the other one? Or do you know? Or is this like...
This is the pattern I've seen.
So
this way of saying, the way I've generally seen it used is kind of downrank this one, treat the others as like normal priority, but treat this one lower. So I think the default value is 1, or it's either 1 or 0. If they're all equal, then overload resolution happens within that group, I think. But this is commonly what you see is you'll have I will bet that 99% of these attributes in the wild are all -1. It's just like, don't pick this one, please. Like, this is the last one you pick, because it's sort of clobbering the one you want it to pick in lots of cases. So yeah.
Okay.
And I can only do it within the library or within the type. I can't like I can't mess with somebody else's.
No, unfortunately not. Yeah.
Things, right? Okay.
yeah, that's a shame.
Well, I guess overall resolution isn't too complicated yet.
Yeah. Okay. So one that might be actually fun to use. These will be fun to use, but yeah. So this feature is a new keyword, field keyword. It's what we call a contextual keyword, and it's in preview. So if you use .NET today, the .NET 9 SDK, and you try this out, it won't work unless you change your language level to preview. So it's kind of an opt-in thing. And this is one that Microsoft have been talking about for a long time, like at least 6 years, I think longer. They keep saying it's coming in the next version, but now I think it is coming in the next version because they've shipped it in the preview, right? So, yeah. And one of the problems with this is they've always wanted to use this as like the guinea pig for how do we solve backward compatibility breaking changes. And to be honest, I don't know that they've solved that yet. Still, I still, from what I can see, think that it's just a contextual keyword at the moment. So, just to give an example, let's say you have a class with some properties, and you want to then sort of move from an auto property. So, to be clear, an auto property, say get set, and it's like there's a hidden backing field, and the compiler's generated all the goop for you. And that backing field is what we call an unspeakable name. You can't actually get at it because the name, you can't type it in C#. So it doesn't appear in IntelliSense. And you can't, it's not just any old private field. You can't actually see it within the class. the moment you want to do something on the getter or setter, for example, like you want to trim the value on the set, or you want to do like a change notification, or you want to, I don't know, check that it's in some bounds and throw an exception if it's out of bounds. You have to kind of, you fall off this cliff of simplicity. You kind of go from just a one-liner of get set to, oh, it's a getter that returns the backing field, and I had to give the backing field a name. And when I set it, then you do this whole dance. And the idea with the field keyword is, what if it was something in between? What if it was like, I could express the thing I wanted to, the compiler would still generate me the backing field, but I have a keyword to represent that backing field. And so this is what it looks like. You now have this contextual keyword. So only in a property does this keyword mean what it means. Outside of this context, it's still, if you have a field called field, it's still a field called field. If you have a variable called field, it's still a field. But specifically in the body of a getter or setter, field is now a keyword, and therefore it's not allowed. And that is a breaking change. So if you had a field called field and you returned it from a property, you would need to say at field. So that's the breaking change. So here the getter still returns the backing field that you can't see, but now we can set that backing field with the field keyword.
So the field keyword is now referring to this unspeakable backing field.
Yes. I see. Yeah. And it just means that when you need to do something, you don't fall off this cliff of I need to do everything by hand. You can kind of go hybrid, like halfway.
Yeah.
So, cool. And that's that one. And then another feature they've added is this allows ref structs, and this one's a bit of a again, not one you're going to use much, but it's one of those mind-bendy ones a little bit, right? So in generics, you can have a type argument on a class, a type parameter, and you can constrain that type parameter. You can say like where T implements this interface, or where T inherits from this type. You can also say where T is a class, or where T is a struct, or where T is newable, and you can then new up the T. These are all constraining things. You sort of narrow what T can be, and that means it's more useful when you're using the code, inside the implementation, because you've narrowed it down to something you can now make use of. However, we've never been able to use ref structs with generic parameters. Like, they're not allowed to be. This T could never be a ref struct. An example is a span. This could never be a span of T as T. And so they wanted to enable that, but that unfortunately doesn't make sense with this sort of where syntax. Well, it kind of does, but it's a bit different from the others because we're not constraining it anymore. We're actually widening it, right? Because by default, this T is actually all types except ref structs. But now we want to say all types including ref structs, or allowing ref structs, right? So there's this new concept of sort of widening the T. And this is it. So you say T where T allows ref structs. And although you're widening it, what this means in terms of the implementation is that you're actually narrowing what you can do with it, because your ref structs have strict rules around where they can go, right? That you can only put them, they can only live on the stack, they can't go to the heap. So all the things I was talking about before, where you couldn't use them in async methods in certain contexts, all of those constraints now would come into effect because the compiler knows that T could be a ref struct, and therefore T needs to be treated with all of those constraints in place. So this sort of backwards thing where by widening it, you're actually narrowing what you can do with it. So that's why they couldn't just change the default. They couldn't just say all T's could be ref structs, because then all your code would break, because it would say, well, you can't do that with any T if a T was a ref struct. So yeah, and if you don't do much with ref structs, then you're just hearing this like, what are you talking about? But this is useful. Like and if you've ever done something with generics and you try and pass in a span, it doesn't work. And then now you can make it work. So if you have some code that should be generic and should take a span, you can now have generic constraints that allow spans, and then you can make that work. So again, it's useful for those high performance scenarios where you want to start working with spans and redoing spans.
I really like your explanation. I now finally understood, I guess, generic constraints in the first place. So generic constraint is restricting the caller, but gives more power to the callee or the implementor. But this allows not the opposite. So the caller can do more stuff, but the generic constraint can do less because whatever restruct doesn't allow to be.
Yes, exactly that. I like your explanation better.
And now finally it made click.
Good. Yes. So that's all I had. Like, the nice thing about doing this is I get to pick what's interesting to me. So there's other language features that are in there, but they're probably more niche than these, or maybe they're not as niche, but they feel niche to me because they're just not interesting to me. But I like to keep on top of this stuff. So the place, if you want to like follow along with these changes, there's two places I recommend looking at. One is the Roslyn docs page, which I'll show in a second, and the other one is the C# language repo. And the C# language repo is really interesting because they have like weekly, well, more than weekly discussions on all of these features, and they talk about like the real intricacies of some of the problems that some of these language designs create. And so if you're already into that sort of stuff, then this is the best place to go. But if you're kind of more of like, hey, I just want to know what is going to come in the next version, and I want to know before they blog about it, this one's the best one, Roslyn docs, because by the point Microsoft are building these things, they're mostly committing to it. Like if they've got to the point where they're actually going to build it, then it's been agreed far enough that it's coming at some point, right? So let's take a quick look at that, because there's some cool things. If I go into Roslyn, so if you go to docs, and the place to go is language feature status.
Would you mind zooming in a little? Oops.
Absolutely.
Yeah. Not a screen share break.
Shall I hit share again?
Yeah.
Let me share this one. Yeah, so the place to go is here, language feature status. So if I scroll down and go back to C# 13, you can see as C# 13 was being developed, you would see here the various feature branches and the PRs and like links to the definitions or the specs of what they were building. So you can see it all here.
And also the developers. So if you want to, if you're unhappy with something,
yeah, this stuff, I've had a look at this stuff before, and I was like, I wonder how hard it could be, and it's like it's really complicated. But if you just like, sometimes you're just curious, you just want to have a look, right? So some of the things that are coming, some of the things that haven't made it that I was hoping for. So the big one is extensions, and we can talk about that in a second. The other one, I think I said last year I was on here, I said, in C# 13 we'll get dictionary expressions. Nope. We haven't got that. Although it looks like this week some more details were ironed out. And again, like if you just want to see that I'm not making this up, of course I'm not making it up. But like, you might doubt me. You can see like this week and last they talked about extensions, but they also talked about dictionary expressions. So you can kind of see here, not that one, this one. Conclusion, general proposal is accepted. So there's still some more work to do on some of this stuff, but it's moving along. So you can kind of keep an eye on how's this feature going. But coming back here, this is where the actual Microsoft are building it comes from. So here we see obviously the field keyword that's already in the preview, but you can kind of keep an eye on how that's evolving. An interesting one. Oh, okay. Runtime async. This is one of the ones that's interesting, right? So runtime async is one that hasn't been in the. This is a weird one. It's not in the language discussion, so that's one of the reasons you don't see a link here. This is actually a runtime feature that they're building, and what this is Microsoft has done some research around looking at things like green threads. So the way async works in .NET is you have the C# compiler lowers the code into the state machine, as I talked before. There's a lot of messy stuff that happens at compile time, and the runtime doesn't really know much about async. The runtime has you've got the thread pool, and everything kind of abstracts over the top of the thread pool, which is just native operating system threads. What languages like Go do is they have something called green threads, where they actually re-implement threads from scratch. They're not operating system threads; they're their own re-implementation of threads. And Go is crazy fast. And so the idea was, well, why doesn't .NET look at that model and see if that would be good or better than the current status quo? And they did a report on it. They did some benchmarks, and they actually did a whole proof of concept that worked in some scenarios. And the numbers were comparable to the current implementation, but they weren't where they thought they should be. So to kind of give that some context, Microsoft weren't expecting when they build green thread support that it would be better than the current version, because they would need to sort of spend a lot of time in performance optimizing it. But even if they performance optimized it, they could see that they were never going to get leaps of performance benefit. So the other option they've got is actually having a runtime aware version of async as it stands today in C#. So when they initially implemented async, was it C#5? I think C#5. That was for .NET Framework, and so they couldn't really make changes to the runtime feasibly to support async. So it was really like a retrofit. So what they're thinking now is, what if the runtime knew about async? So what would happen with this language feature is it would generate the async state machine, but that would be like a fallback. That would be for runtimes that don't natively know about async methods. And it would then emit something different. And I'm getting woolly on that because I can't remember the detail, but it would emit a different path for new runtimes. So for example, maybe .NET 10, if this landed in .NET 10, maybe the runtime would see this more optimized path that wouldn't need to allocate the state machine and could actually handle the async state natively. And that would be, looking from their projections, that would be much faster than even green threads. So what we're getting is something more performant that still uses async await. So one of the benefits of green threads is you don't need async await. You can actually just mix async and sync code. And if you come from the Go world, you know that's one of the nice things, is you just write code and it all just works. But yeah, so that's a really interesting one to keep an eye on. And the other one is, go on.
Sorry, but so the runtime async, it wouldn't change anything about how we write and discuss async code with async await.
No, exactly. Everything would work exactly the same. The way that exceptions work, the way the only thing that changes is performance characteristics. So that would change.
So
But
it just gets faster. Okay, that's
it
amazing.
just
Because I spent 10 years learning that. I would be sad if it's all gone now.
Yeah. Well, it could have gone a different way, right? If the green threads thing came about, it could have all been a bit different. But no, everything you know today is still relevant in this new implementation. So we'll see how that goes. It's a massive change in terms of the implementation. I can't see them landing it as not a it would have to be a preview feature in my mind. It has to be a flag. And we'll probably forever be compiling code that has the async state machines for today's runtimes. But potentially async gets faster is one of the results of this.
Cool.
The other one, I won't go into it because it takes a while to explain, but one of the big features of C#13 was going to be extensions, and that was going to be like the big headliner. And they got quite a long way through the design for it. And then when they came to sort of come to the implementation, they ran into a bit of a roadblock where they realized they couldn't do it in a correct way, in a way that the architects on the .NET team were happy with, because technically it wouldn't have been safe. So they had to sort of go back to the drawing board. They've just this week landed on a new proposal off the back of that sort of roadblock. They kind of went away and came up with lots of different designs. Back to the drawing board. They've come up with competing designs. They've now come back to a unified design, and I can show a little bit of that because they talked about it here actually in the latest.
They have quotes of the day. Okay, I will. So far, I haven't. From now on, I will observe this closely.
It's good. It's good stuff. Yeah, they always have a quote of the day.
Yeah.
Here we go. The extension unified proposals. So they had a bunch of proposals. It's now coming back together. The idea with extensions, and if you've used other languages like, I don't know, Rust, where you have you have roles and traits, it's like that. But I have to admit, I've not used that, so I'm alien to the terminology. So they're going with something like this at the moment, and this could definitely change. But they're kind of coming up with this concept where we have an extension, and the idea with this is kind of we have extension methods, but you could have extension anything. You can kind of have properties and methods and whatever. You can kind of wrap types and give them more behavior. And there's lots of ways that this is nice, and I won't go into it today, but there is a proposal here you can look at, you can read, and you can get a feel for what's being proposed. And that seems to be converging on a path that might make its way into C# 14. So fingers crossed.
Awesome.
Still fingers crossed.
Yes.
Yes.
Indeed. So that's what I had for C# 13. Do you want to cover some of what's new in .NET 9? I'll throw over to you folk.
Cool. We have, maybe before we do, I'd like to dive a little bit deeper into the features you just showed, because I copied a bit of code and wanted to kind of confirm the thing and also look a little bit behind the scenes. So I'm now having here a benchmark. Well, we still need to do a benchmark.net episode. We promised
Yes.
this for way too long. Next season, It's time. A little benchmark where we have a params array and we just sum them up and return them, and also a params read-only span, and we just sum them up and return. And then passing in all the C# language versions, I think. And when we run that, it is, well, we are in the nanosecond area, but it is double as fast. And we do indeed not have those allocations. That's really cool. And now I'm wondering, with the what Eva mentioned that we did last time, could we do this with any type, really? So could we have my collection kind of a thing?
Should we try?
If we have, I should have watched the episode from last time. I think we need, well, I guess we just yes. Okay, cool. So we need a my collection.
If you want to watch the episode from last time, please head to our YouTube channel.
I should do so on the side. So if we have, well, this is not so my collection of T. Okay, so let's make this generic. And let's not think about the algorithm, just a method that takes it. And now, well, actually, what do we need in order to make this make this collection expressible? So let's make this I should do a T here. So if we have a my collection of integer, now this doesn't work because it's not constructible. We need this collection builder, attribute. And this one takes a type and a method. I think, if I recall correctly, I think this can't be on a generic method. So let's make a static non-generic generic class where we now have our static my collection of T returning create.
Yes.
That takes, I don't think a T array, but read-only span of T, because these days everything is read-only span of T. And now let's say type of and name of my collection dot create. And well, I'm just returning null here for now, but just to get it compile. And this does not work yet because no iteration type. Oh, it must be an enumerable.
Yeah. I think we ran to that last time. I think that was one of the gotchas. Yeah.
Didn't learn anything.
No. Cool. Okay. So this is now collection expressible. So can we now some array that cannot return from voids to so because this doesn't, let's let this method return float here. Let's return 1. But this compiles. Cool. So we are now just building it because I want to see what happens under the hood. So we are now having our custom collect. So I guess, this really, so we could do the same as well.
You see Rider puts the little, why is that red?
It says redundant.
Yes.
The red maybe sometimes with screen share, the reds go a little bit, but it does compile, but we don't need that anymore.
With screen share or with code
screen share with code with me, yeah. And under the hood, it does something one-time helper. Okay, so it does statically or like.
Yeah, you see that
it makes that into it. It's create. Oh yes, create span.
Left of create span. Yeah, so you've got. If you go left a little more,
there it is. There it is. Mm-hmm.
And then it's making a span to.
Passes a span in, yeah. And this is then some. So this is based. So this is now baked into my assembly. So it doesn't allocate anything if I get that right, and we just get a span of that field ref. Okay, something unspeakable.
Wow.
Cool. And what if now? You also mentioned overload resolution. What if now I have also, maybe I am building a library and I don't want to break existing, I don't want to do, binary breaking changes. So maybe I need to support this forever, but it's still the my collection chosen because my collection has more precedence over the array one. Is this like a language rule? What happens if we also have a span version? Okay. Now it's not distinct. So we have two.
Is it something to do as well with some array has an int array and there's floats in there or not?
Well, I was hoping to say, well, I'll just make everything. Maybe, there we go. That's int. Let's change it all to ints for simplicity. And let's make it all non-generic and just int. Oops. Right, so we return, let's be consistent. Okay, cool. So we take a bunch of ints and we return one int. And now it says, also the array. Okay. So is this one already ambiguous? Okay. So I can't have multiple. Does this mean every time I do params with 2, I should think about the overload resolution? What's it called? Attribute. Overload resolution priority. So we want to deprioritize the array.
No.
So, but then we need to think, do we want to do our custom collection or the read-only span? Well, maybe, I guess the compiler usually knows best, so maybe we give this a -2 and or do we just deprioritize the other ones that also -1 and now it does compile. So the reds those are just from rendering, but it does compile.
Awesome.
Very cool.
And is this so this is now the new attribute, the params collection attribute. And for array, that's, where is it? Oh, does the compiler kill it because it's never called? New, yes, autocompletion.
Okay.
So the array one gets a params array, well, in metadata, and the new ones are params collection. Cool.
I have a question. Because with the priority again, because you lowered the priority on 2 of the summary thingies, but when you only had it on 1, it was still ambiguous. So if you, right? Yeah. So if you lower the priority of the second summary now, so not this one, yeah, this one. Why is it not ambiguous now? Because they're again on the same priority level, right? And they are
no, because this one
ambiguous on
is
their own. Okay, but when
this one is
when
default.
this one doesn't work for some reason, it would then go to the next priority one, right?
Oh, if this one doesn't work, let's say maybe let's make this a float, so it's a different type. Now, well, which one is it taking? It is actually taking float because integers are convertible to float. Let's do something that is not convertible. Let's do something less. Let's do byte because integers are not lossless convertible. Maybe let's do a big number here, int.max value. And now it gets ambiguous again between the int variants because it cannot use the byte variant because int.max value is too high. But actually, which is cool, if I only go to 13, which is within the range of a byte, it will still pick the byte.
Yeah.
That's really cool.
And then we could lower the priority again to -2 or something, right?
Like from this one?
Yeah. Well, from the 2 ambiguous ones.
From this
like one,
these?
Yeah, and then it would still work, right? No,
Wouldn't be any difference.
sorry, I'm not making myself very clear. So like when you have those 2 on -1 and we had this max value, it would again be ambiguous, but then you just lower the priority even more for one of them. And then
I don't think this makes a difference because if you do int max value, so now these are not convertible to bytes.
Yeah.
So this one is out of the picture.
Okay.
But these 2 have the same priority. So which one? So it's now ambiguous between the 2 of them.
Yeah, and then if you do 1 - 2, yeah.
I guess then it's Now we take the my collection.
Yeah.
And if we vice versa that, then we should go the array.
Awesome.
Yes, we do.
Awesome. Is there also like a max? Like, is it minus?
So that's an integer. So yeah.
Okay. All right. But I won't
value.
Ever.
This is never picked.
Okay, cool.
That's cursed. never use that.
Okay.
It will never be used.
Okay.
Okay, cool.
Let's remove that.
Awesome.
Cool.
Sorry, I was not making myself very clear. And also, like, we're doing code with me, so I could have just typed it myself.
Right. I also draw the example of the state machine thing because I also want to see how this works under the hood. So we can't do that, right? Because we now have the bytes, we use them here, we have an await here. We can't use them afterwards because this would be a member of the state machine. well, I guess this can't even try, right? So here's now our state machine. Where's our state machine? This is our state machine, where we now have our move next method, which is called in this case, I guess, twice, where we have here our task delay. And okay, it can't really depict that. I guess, well, it doesn't compile, so I think this is just still obsolete.
I thought the stell worked on the compiled bytes.
Yeah.
I think you get a stell version.
Yeah. So I'm now trying, but an array would work because that's peepable.
Yeah.
So if we were to create an array, and let's do the same thing as well with the array and use that down here. If we build that, we now see that state machine move next. That, this dot array. Yeah. So this is now a field of the state machine. This one, right? So, okay. So our local variable that is crossing the arrays is promoted to be a field on the state machine. And the state machine is a class. I think in release mode, it's a class. In debug build. In release mode, it's a struct. But neither a struct nor a class can't have a ref struct as a field. Only ref structs can, and therefore it doesn't work. I see.
Yes, exactly that. Yeah.
Cool. And if we had green threads, it would just be faster. Amazing. I also took a big look because we mentioned polyfilling. We actually do some polyfilling in our code base already, quite manually. We have, in .NET 7, they added the string syntax attribute. So we don't have that in .NET 6. And we are using that in one of our tests where we attribute a method. Okay, this is an unused method. Perhaps we should find a used method. There we go. With, hey, this is the string that you pass here, C#, and now the editor is free to render this as, now this was string literal that you pass, but it renders it as C#. But it wouldn't work in .NET 6 because attribute isn't there. But we polyfilled this attribute for .NET 6 build, and all is good.
Nice.
Yeah, and you could have gone with an off-the-shelf one like Polysharp, but then you're bringing in lots of, other things. You might want to be more, deliberate as you are being. Yeah. But yeah, there's a few. There's Polysharp. There's one from Simon Kropp that I can't remember the name of. There's sort of three main popular ones that people are using.
Look there. It is already there. Cool.
Yeah. Yeah, and I think there's an issue, maybe not on this polyfill, but there's another library that has an issue around the lock where they've tried to polyfill lock. I don't know if this one even tries to do it.
I took a look at the source code of lock and source.net, and it's like a lot.
Yes. Yeah.
And I think that's not even. I think it's even a partial type, so there's even more.
And it hurts your head if it's really it's really complicated for sure. Yeah, you don't just copy paste it.
I see. So then also, if native AOT, okay.
Yeah. Yes.
I see. Is there one thing? Oh yes, the last thing I also wanted to take a brief look at is the field. So if we have, I quite didn't do that yet. If we have a class and we do a property, and we wanna set field, what was that value .trim, right?
Yeah.
So this does not work because we are on C# 13, not on the preview. And now with cool.
Yeah.
Nice.
Yeah, and hats off to Ryder for having that on day one of .NET.
Yes.
9.
Yeah.
It's pretty good.
Yeah, for sure. And it doesn't break anything to have this opt-in for us, right? So that's good.
Because we don't have, I don't think we have fields called field.
Yeah, good.
I hope.
So we can already use it.
Yeah,
Awesome.
you'd have to have a field called field, and you'd have to have a property where you touch that field in the Nestor Guesser.
Oh yeah, because now this field it's not used. I would need to. You mentioned the add character.
Yes, and that's a way of sort of saying the symbol field as opposed to the keyword.
Yes, and now this auto property doesn't work anymore because there is no auto-generated property anymore.
That's
so
right.
I would also need to do add field because this is
okay.
now I could do field, but yeah, add field. I see.
Oh, that's cool.
So never use field as a identifier, but this now I see why it's contextual, because it is actually every new keyword that they introduce in C# contextual.
That's a very good question, and I don't remember. I think pretty much, because you could have a variable called anything, and they're pretty hot on backward compatibility. So you know, I'm trying to think of, you know, you think of what is it? Allow ref structs. That's contextual. You know, I'm trying. I can't think of a keyword.
Right, I can have my await and my allows.
Yeah, there's some really funny ones from Johnsky and Jared on the language design team, where they come up with like a wait. You can write code that's like ridiculous if you set everything up just right. You can have classes and fields called await. You can await. And you can var. Wait. You can be really devious.
Also...
Yeah, you can do some terrible things.
I see. Cool. Sorry, I missed one message from Eric. Yeah, we could have also done positive. If
you can, to the... So the default is 0, and you can go up or you can go down.
So if we have ambiguity, we could say...
I think... I don't recall there being guidance on this, but I would suggest that this is something you use sparingly. Don't just like come in with the manual ordering of overloads. But I generally see it as like push things down a little to allow for the new thing. But equally, it may be that you want to do it the other way around. You want this new thing to come in and win. But I don't know.
I guess it depends. If I would only deprioritize 1 or prioritize 100, maybe is that the approach? Like the thing that I need less of?
Yeah.
Do you know does this make sense?
I think I know what you mean. It's usually like, yeah. If you deprioritize 1, you're already solving your problem, and it's I guess better than to put priorities on multiple things. You just prioritize the one that's deprioritize the one that's less important. I think we had like actually an issue like that with one of our overloads. I can remember where it was ambiguous, and then we had to sort of like pass in another field that I think changed the type. And we could have just used this attribute.
This is like a get out of jail. It's like an escape hatch where you get into that knot and you just need a way out. And this is that way out now.
Cool.
Freedom.
Freedom.
Good evening, Toast and Training. Thanks so much for joining.
Cool. Yeah. I also want to take a look at. Well, there is a lot. I guess we could fill a year of content. The .NET SDK has 3 features that impact us immediately. One is that tests now run in parallel. Well, multi-targeted tests, that is.
Yep.
So if I were to go to... do we need any of that? No, it's just committed. If we were to jump to a different branch, where we still use I hope this doesn't break everything now. Where we still use the .NET
Restore failed.
8 SDK. Let's see. Let's open a Windows terminal.
Oh.
And if we were to run .NET test here, we have, well, all of our tests, I hope this compiles now, all of our tests are, also our tests are multi-targeted because our production goes multi-target, so we also multi-target our tests to really cover all of the permutations, since we also do polyfilling and all of that a little bit. And now this will build, and this will start running soon. But we now have 3 target frameworks for our tests, and previously they were now with .NET 8 SDK or earlier. These multi-target tests, they don't run in parallel. Well, I think the test assemblies, they do run in parallel. So no, like tests within a target, they do run in parallel, but I don't think the multi-targeted tests really do. So we are now going to the land of our integration tests. They do a lot of file operations. We have quite an amount of them. They do take a while. And yeah, we will see this now will run for over a minute or so. And hoping everything is green. Everything passing, but it took like quite a while.
Yep.
Now going back to our new thing again, where we have the .NET 9 SDK. Well, first of all, we see it's now using a new logger.
Ooh, yeah.
A terminal logger. It's more, doesn't look fancier. The progress is, I still haven't wrapped my head around what's going on, but it looks cool.
Yeah, more colors.
And it does, and we see already, Net 9 and Net 8 are also running, also the multi-targeted tests run in parallel.
Wow.
And these should now finish.
Yeah. We should have had a stopwatch.
Than before, at least, I hope. What did you say? Like these took like 20 seconds? But yeah, so we see already, it's really cool because it really shows they do run in parallel, those multi-targeted tests.
Yeah.
And our CLI tests, those are the ones that take more than 20 seconds, even longer. But that's really, this should shave us a bit of time that we spend in the CI. And this takes, of course, longer than expected now. There we go. But I really like that they run in parallel now. That's really cool.
Yeah.
I think in general, about when it comes to testing, there has been a lot of new changes. I don't know quite all of them, but there is many. And another change is also
there is like a new test. They call it Microsoft Test Platform or testing platform. So it's a replacement for VS Test, which is quite a big change. But they haven't sort of pushed it yet, so they're still waiting for the test frameworks to all adopt it. So XUnit 3 is built on top of this testing framework. So it's Microsoft Testing Framework.
I believe, we are still on 2.9 point something. So that's that. Oh, okay.
So most people are on version 2 point whatever, because version 3 is still like being cooked. But the new version of XUnit uses this new platform, as does a new library called TUnit, which is so it's another testing framework, but it's like a source generator thing. And what I like about this one is you have more control over like how things run concurrently. And yeah, something else to look at, just throwing things out there. But like this is also super cool as well, because a feature that's currently unique to Visual Studio is you'll be able to do hot reload potentially with this, because the way it works is you actually compile your tests as a console application. You can actually just run them, and they just self-report whether they fail or succeed, so that it can be used with native OT. But also the way you use it in IDE is it runs them in like a server mode. So it also contains a gRPC server, so the IDE can talk to it and get the results out, and it can kind of keep it running if it wants to and hot reload it. So they haven't done much like publicity around this yet, but there's a big change around here coming soon that I'm really excited for. And Ride already has support for it as well, which is I was quite surprised by. So
Awesome.
very cool.
That's the new testing. Is this now hot reloading for tests? I think about continuous testing,
Yes,
kind of a thing.
Which
Is this
was
where we could get?
enterprisey paid thing. That this might fall under that, but I'm hoping it won't. But yeah.
Ooh, I'm kind of hoping. Could this also tie in? Well, I think there was what's that .NET Watch test. I'm rarely using it because I always use the thing from the IDE.
Yeah,
but maybe this also ties into that.
I do not know, but I would. That's what I want.
Cool. Okay, so we need to upgrade our source generated tests. This is how you get me.
Yeah,
source generate anything.
You don't need to upgrade because I warn you. Like I keep doing it for one of my projects, and I keep just like shelving it because things aren't quite ready. Like if you want to try and do mutation testing, can't do it. Like there's a whole bunch of things. You just run into lots of little edge cases. So I don't think it's quite ready for the masses, but it's coming.
The T-Unit or the new testing platform?
The new testing platform. Not. There's nothing wrong with it. It's just like you have to wait for all the IDEs to have proper support for it. You have to wait for everything to kind of, everything to get there. Like XUnit's not there yet. It's still getting there. So
not yet. Okay, cool.
Okay, but something for next season.
Yes. And there we go. Testing. Also roll forward policy. I think we mentioned this briefly in a previous episode where we just briefly as a teaser. What we don't do in our .NET tool, well, we do multi-targeting. Well, previously we had 6, 7, 8. Now just for this demo, I'm having 8 and 9. So this will run if the user has the .NET 8 SDK installed or the .NET 9 SDK installed, then the correct version will be used respectively. But I mean, with the version that we currently have published, everyone is targeting 7, 8, 6, 7, and 8. So if that's like the one, you know what? Let's actually go to NuGet. We have frameworks. So we target 6, 7, and 8 with this version. But if I wouldn't have the .NET 6, nor 7, nor 8 SDK installed, let's say I would have 9 SDK installed, it wouldn't work. So we would need to also multi-target that, but that's kind of tedious, and also we need to be up to date so that everybody can use them. What we could have done, what I didn't know actually is, or I didn't think about, there is also roll forward policy. .NET roll forward that you can set, because by default it doesn't roll forward to a major version, because technically there could be breaking changes. Well, there always are some breaking changes, not like rather in not the most dominant aspects, but here and there sometimes are breaking changes. And roll forward, what we could have done to enable this is also to like latest major here is a roll forward policy on our application, which would now, if we would have deployed that or would have published that, it should also work with .NET 9, because, well, if there is no 6 or 7 nor 8 SDK installed, it should now roll forward to the latest major version that is installed on the machine. But yeah, since we didn't do this, there is now with the latest SDK also an opt-in for users to force roll forward policy, a little bit on their own danger. That's not English, but because technically there could be breaking changes, but to get it working, usually it kind of works. You can now, when you install a tool, you can say allow roll forward. Let's actually give that a try. We do consume one tool. from Matthias, the Nuke Global tool.
Yes.
Let's bring up our.
If you're
.NET
interested about the
tools.
tool, head to our YouTube channel and watch the episode. Oh no, we need to have like a little pop-up or something.
For next season, yes.
Next
inserts.
season.
Oh.
That was a really fun episode, but that was I think one of our longest ever.
Yeah. Yeah, we only went over by 2 hours.
Yep.
So I think what we can now do is install it with this roll forward, and now we also get. I was hoping for a true here. Maybe I need to uninstall it first. Well, I guess I could set it to the true, but I don't wanna. Let's uninstall it. It's gone. And now let's install it with roll forward. And now we have to roll forward to true. So think version 9 of the Nuke Global tool needs .NET 8. So even if I wouldn't have the .NET 8 SDK installed, but .NET 9, it would now roll forward and would still work if it doesn't use any code that has breaking changes. I think now the latest version is also no longer using the binary formatter, because the binary formatter now, that's a dramatically breaking change. It's no longer, it's totally gone now in .NET 9. Well, you can't bring it back, I think, with some NuGet package, but you shouldn't use that. And it doesn't, the latest version doesn't use it anymore, so we should be fine rolling forward to the latest SDK, even though it's not targeting .NET 9. So I guess now for our tool, we could think of how do we want to continue? Do we want to do multi-tagging? Yes and no. And do we want to do a roll forward, or do we want the user to opt into the roll forward? Because technically there could be a breaking change here and there.
Yeah. I mean, my first instinct was to just do the roll forward, but maybe you are right. Maybe we should give the option to the user to opt in. Just to be on a safe side. I don't know. But when you first, I guess, mentioned it, I was just like, oh my God, all our problems solved.
What would you do, Stuart? If you were publishing
not sure.
a technical...
I'd go away from the idea of having the user do it, just because it
Okay.
feels unwelcoming. But like putting the roll forward in does feel sensible. But then you're not guaranteeing that's going to work on the latest runtime. But to be honest, like I would go with roll forward, but it's much of a muchness. I think either option's fine, to be honest. If someone reports a bug and says there's a glitch with it, then yeah, you can always look at it. But
so you would choose this this option to roll forward on an app level?
Yeah, but if it goes wrong, I said nothing.
Okay.
Nice.
Not we edit that out. Well,
I think
we add to the.
Yeah, go on.
Excuse me.
No, go
on. I guess we just add to our documentation. I guess we should have that already. We just add. There we are. Requires and supports. Oh, good. That's our what's the word? Scapegoat documentation.
Nice.
Yes.
Cool. Yeah, those are the features that are directly impacting us from an SDK perspective. .NET 9 has so much more. Like they have I don't know how many new in the libraries, at least that. Actually, we can check. There is this amazing site, APIs of .NET, which has been where we can also get the diff between 8 and 9. So in the BCL there is 100. Okay, there is intrinsics 1,800. There is 2,500. I don't know, new and changed APIs.
Wow.
Yeah, it's really nice. And like a lot of them are around performance, like you say, like the intrinsic stuff. And Stephen Tobe, is it Taub or Tobe? I forget. But he does this annual blog post that's like that crashes. If you try and read it on your phone, it will crash your phone. But it's like this massive write-up of all the performance improvements. So for me, that's like one of the biggest things in .NET 9 is, as with every release, they're just massive performance improvements. Specifically in .NET 9, huge improvements around link performance. So link is much
Ooh.
faster. And they've added
Mhm.
some features as well around link. So count by is now a new one. So you can say count by, put in a lambda, and you now get key value results of the key and account. There's also an aggregate by function as well. There's a few. Oh, dot index is a nice one as well. So let's say a list of things, and you wanted to for each over it, but with an index. You just, there's an extension method on link on INumeral dot index, and you get now pairs of results. These are all just really nice for like advent of code, for example. If you're doing that now, then these are just the handy little things.
Let me just remove the net 8 target because we don't do polyfilling yet. Index. So this is now item, and this returns a.
Yeah, and so you typically deconstruct it in place. Instead of item, you'd say I.
String item like so.
Yeah. And then just, it's so small, but it's just very nice.
And we now also have. Yeah, because previously I was like adding a for loop, no, a for each loop, but then doing an I++, and now we get that off the box. Okay, that's really cool.
Nice. Yeah.
What was the other one that you mentioned? Count by?
Count by, I think, is new. So you can say count by, then you give it a like a lambda. So whatever. Not a great example here because you're like, you can say length, for example, and then you what you get back is a group.
Oh, I get another.
Yeah, so say var group, and then if you dot into group, you've got. Ooh, wait a minute. And count by. I was not expecting that.
So is this now?
Have I got that wrong? What is this? What is this? Count by.
So this is also grouping it. Does this mean we now have 2 3s and 1 5?
Let me look. That's confusing to me.
Let's run that. We have because we do the length, so we have 3 3 5.
Oh, yeah, the key is the length now. Yeah. So that's a weird one, right? Yeah.
The key is so because I have the length. Yeah.
Yes,
So if I were
that's how it works.
something more. Okay, well, I guess maybe something more sensible if I were to group by the like how often does 1 occur? If so, we could group count by the item, and now we get an string int key pair, and we now see that makes way more sense. Yeah, man, that's cool. Oh, that's really cool.
Is that going to help us with using counter?
This
tests at least.
Using
or not?
Perhaps. Because if we do grouping, we go for all the because we do need the identifier as well. Perhaps we could write this into one big link thing.
Yeah.
Where we like, okay, we do, and we count by this.
Nice.
And then we definitely need polyfilling for the non targets. Okay. To do polyfilling. Well, not manual because we do it currently manual, but use some NuGet package for that. Can you think of any other improvements from the libraries or from other aspects that?
There's lots of little ones. Like there's ordered dictionary is a new type they've introduced, which is a common request, and that's like used. They were using internally for JSON object under the system text JSON nodes API. So that's a nice one. What else? There's lots of stuff in and around .NET. So, for example, like the one I'm most interested, massive link thing, scary. I'm quite excited for Aspire, which it isn't. I don't think it's going to be much use here, but like just working at a place where we're building microservices, like Aspire has really helped us massively, and this release has been like spot on. Everything we've wanted, they've implemented. So quite excited for that. That's on its own release cycle that's independent from .NET. They sort of coordinated the release a bit this time for Aspire 9, but it works with the .NET 8 SDK, and in many places that's what we're using it with, and it works really well. So yeah, lots of nice things. ASP.NET Core. So other big ones are it now has built-in support for creating OpenAPI documents or Swagger documents, if you will. But they've dropped the templates now drop the like swashbuckle packages by default. So you had to add those back in if you want like Swagger UI, or if you want some other UI for it, you would add that back in yourself. But yeah. And yeah, I don't follow Maui much, but yeah, there's lots of stuff happening in all the various places. But yeah,
there's so much. I barely follow EF Core. I know the only thing I learned about F# also has nullable reference types.
Oh, that's a whole. Yes, yeah. If you want to talk about nothing, you got your nothing talk, right? Yeah.
Yes, I actually give the end of January. I need to revise that. Yeah.
Yeah, because when F# was created, it didn't have null in the traditional sense. You can't define, because everything's immutable. You can't sort of define a variable that's not initialized and then initialize it later. I say that you can go out. There used to be like unchecked dot. There used to be a really horrible way of actually kind of producing a null value that was like really hard to do. But unfortunately, because you're interacting with C# often, you can get null still, because you call C# code, you can get back a null. So when the whole nullability thing happened in C# land, it was kind of really weird from the F# world, because it was already solved in F#. And so they finally kind of got a solution where you can now, F# now understands the nullability from C# and has syntax for it, and you can pass match against it. And yeah, that's the whole thing. That's interesting.
You know, does this also include all the nullable attributes? Because in C# there is this whole slew of attributes, how you can refine the nullability annotations. Is this all understood here, or is it only the question mark, more or less?
It's from what I understand of this change in F# 9, all that metadata is now understood from the F# side. I don't know if you were producing types for C#. You typically don't do that anyway. Typically what you do with an F# library is, like, if you were exposing something that was going to be used with idiomatic C#, you would add a C# project that sort of wrapped it. But some don't, but that's typically what you do. But yeah, so my understanding is this would read all those attributes from the F# reading C#, but I don't know that it could produce them going the other way. That said, I might be wrong, because
the other way. Yeah, I see. Cool. There's even new stuff in WPF and WinForms. Oh wow!
Yeah, I haven't touched that in a long time.
Yeah, I don't think I've ever seen that.
Yeah, no. At my work at JustEatTakeaway.com, we have like an early adopters program for .NET. So whenever there's new releases, like so even like in a couple of months' time, we'll start it back up again for .NET 10. So we'll have the preview builds as they come out. And we'll try out whenever there's something new. We'll try it out for a bit. So Martin
awesome.
Costello, who's my colleague, runs that, and he's reported like I don't know if you search him up, so many bugs. But it's good because like we find the things that we know will affect us, and that so when the release comes out on day one, we know exactly.
Yeah.
We know it works because we know from the RCs exactly what still needed fixing, and so like, yeah, it's really nice to know that on day one for us, it just everything is going to work the way we want it to work because we've ironed out all the issues. So yeah, we're really on the bleeding edge. We love it.
So you always start with. So you always start with preview 1.
Yeah, first preview. We'll try it. We won't run it in production. We'll run it in our QA environments for a handful of things. And then we will sometimes do the RC go live license. We'll put that live, but typically just for one or two things. Like, and then we'll sometimes go live with the new .NET on the day it's released, just because we can.
Yeah.
Did you notice? This is because this is also something that we hoping when we get some time finally. But we don't. In my company, we are not using the preview bits just yet. There is now in garbage collection this. It's promising for server GC that it consumes significantly less memory. Did you observe something like that? That it does consume measurably less?
Yes, but we're still yet to like get graphs together and like really. But yeah, we have seen that. Like we were surprised in places. So yeah.
So then I'm gonna push tomorrow that I want that too.
Yeah, it's cool. Yeah, because I think that causes confusion. I know when they changed something around garbage collection in .NET 8, and it was a bit more greedy. And I know that people were reporting it as sort of memory leaks when there was a memory leak, but everyone jumped on it and thought that they had a memory leak when actually the behavior just slightly changed. But with this new mode, it's way more aggressive in terms of keeping the heap size low. So it just looks better now. Whether it actually makes a material difference is another question. But like it's just nice to see that it's running very lean in the way it performs. But
Wow.
I want to ask one thing. I forgot now. Well, I remember. You mentioned .NET Aspire. Well, I haven't really learned anything about Aspire just yet, but I'm glad that in Vienna we have.
That was good. Well done.
I'm still practicing the advertising things, but we do have a meetup.
Awesome.
In Vienna where we have an aspiring evening and learning everything about Aspire. Yeah.
Awesome.
I think also some change the updates in .NET 9 as well. Do you use .NET 9 early or the early .NET 9 releases for the services or also for the libraries? Because I think you also have a couple of libraries a bunch of NuGet libraries that you maintain, right?
Yes, yeah, and
but I can't think about the name right now.
Just eat without the S. We've got just saying we've got our most popular one's probably that statsd one. It's like the statsd library everyone uses. I don't know if we've upgraded that. I have to see. Yeah, no, still on the old version. We'll have upgraded the SDK if you go to the repo. Like we
right.
we probably, but we probably haven't published anything. So Martin Costello, if you look at the contributors there, the first face, he's another MVP, and he's built lots of automation that we use that saves us a bunch of time because we have like many hundreds of .NET apps, and he has lots of automation he's built to keep NuGet packages up to date and keep SDKs up to date and coordinate things. And he helps me out a bunch because I look after .NET Outdated. So he'll often do pull requests to that and then poke me and get me to look at it. So yeah.
You maintain .NET Outdated?
Yes, true.
Cool. We used that. That's amazing.
Yeah, I didn't build it. I just revived it. So the owner of it,
cool.
who's brilliant, but the owner of it decided he was kind of done and deleted the repo, so it kind of disappeared.
Ooh.
So I sort of tried to find who had the most recent fork of it, tried to sort of ask them to hand it over, so we had a dedicated org for it. So you'll see that it often causes confusion because there's
There's
the there's a .NET outdated, which is like dead at the bottom. We had to create a new, we had to give it a new name.
It's this one, right?
Yeah. So unfortunately, there's that confusion, and people have the old version, they have the different name. But yes, that's the new one that's maintained. So yeah, changed hands
if we do
4 years ago, I think.
Cool. I also noticed that. Oh yeah, upgrade to .NET 9 3 weeks ago. Yes.
yeah. It'll be like on the day.
Not I'm thinking about. I'm not publishing too many public libraries. With that I mean none. Would you recommend always targeting, including the latest target, or only include targets where you actually use features for? So if I have if and def kind of a thing, or do actual polyfilling?
That's a really good question, and we keep going around in circles on it. I don't have a good answer, because I feel like if it's an ASP.NET core thing, I feel like that's even a different question itself. But for just plain libraries, like that's the one. In theory, nothing needs to change. If it's targeting .NET 6, okay, .NET 6 that support, but there's nothing, like if we upgraded it, we could take advantage of new language features, but nothing, if we don't change the syntax or anything, nothing changes. But it's funny, you still get people create issues on your repo saying, oh, can you upgrade it to .NET 8 or .NET 9? And you're like, no, it already works. Like, there's nothing to do. It just works. Like, do you have a problem? And they sort of think that either the TFM being old is a sign that the thing is sort of not supported, or it's a sign that it doesn't work, or it's not tested, or not compatible. So there's that at play. But yeah, there's also like, do you target .NET, 8, 9, and then 10 when it comes out, or do you just go to the lowest one? I don't know. Like, I feel for .NET, new .NET, I think you just single target, to be honest. We've preferred in some cases to target .NET Framework explicitly and .NET 6, and sometimes .NET Standard as well. There's no need for it. Like, I've had a debate in some of the issues you can see on Shouldly around with Simon Kropp around Net Standard 2 support. There's an argument that we should just drop it and explicitly target all the TFMs. There's no right and wrong. It's just a really messy, it's not messy, but it's like, there's just trade-offs of really niche cases. You could argue it both ways. I find it really hard to get excited about a specific answer on it. There's not one right answer.
I see. Now, since we're on the topic, I want to ask one more question about it. I know it's a little bit off topic, but now I'm intrigued. What would you, let's say I'm targeting Net 7 currently, and then it goes out of support in 5 months. Should I, it's for a library, should I drop that? Or is it actually, it's not a runtime, so does it really matter?
Yeah, it doesn't matter, but I would just do it just because you'll get errors in the CI unless you say, you have to say in your project file, like, allow unsupported TFMs. If you build it on a newer SDK with the older runtime, it will just shout at you, or it'll warn at you at least. So the fact that you have to like put config in to allow it to build on the old thing, it's like actually just tidy it up and bring the TFM up. But like some of these things, like this one here, targets .NET 6, we haven't needed to put a new version out. But if we did, we would, we would have Net 7 as the TFM. Wait, hold on. Net 7? Yes. No, Net 7's gone. It went in May. Sorry, Net 8.
Yeah. But then do drop, remove TFMs once the SDKs go out of support.
Yeah. So I think that is the minimum that you would do. I wouldn't go out of my way to release a new package, but actually, if it's been a while, someone looks at this and goes, these I don't know, they won't make that noise, but they might they might judge us, is what I'm saying. And so I think at some point probably I will push this out with a new TFM just so I avoid the judgment. But there's no technical reason for it, right? Yeah, the other interesting one, because that in itself is a whole discussion, but then the other interesting one, and there's more validity to that discussion, is how do you treat any dependent packages? Because if you publish things that support .NET 8, for example, so look at which packages do you support? Here, dependency Microsoft.extensions.dependency injection.abstractions, that's version 6 because we're targeting .NET 6. But if you were to target 8 and 9, would both versions target different versions? And that that question is a really complicated question. There's not a really clear, crisp answer as far as I'm aware. And if you look at different packages, they have different approaches. And I don't think it's like a massive deal breaker because packages have different approaches and it seems to work mostly fine. But I know that things changed in .NET 6 when it was released, and there was a blog post by Andrew Locke who talked about how some of these packages they push out where they upgrade the version and multi-target runtimes, they don't actually check that the runtime will work with it. Like there'll be things that blow up at runtime, and so that threw a cat amongst the sorry to use an expression, a cat amongst the pigeons, because everyone was then worried about referencing the newest package. So yeah, sorry, that's just I'm giving a really messy answer because there is no like good answer.
So for what Eric is asking, so for apps, I guess if we go to our tool and we change the 8 to a 9, we should get all the Stephen Tobe performance improvements. What about
tools,
libraries?
Yeah, tools and runtimes, so apps and runtimes definitely, but then libraries, you have to go and make it faster. That there are cases where that may not be true. For example, like collecting expressions, they might change the implementation. You upgrade the compiler, and the thing goes faster. There have been features where you just recompile and it goes a little bit quicker. But for the most part, those are very few and far between. So usually just changing the TFM of the library doesn't change the performance unless you then go and adopt the new feature that's a faster way of doing things.
Right. If I use the what's the one super hype, like all the new
search values is a nice new one that they've added. That's really nice.
And the 1,800 additions to hardware intrinsics.
Yes, exactly. Yeah.
I see. So I should really upgrade. I shouldn't just upgrade. I shouldn't just library upgrade for the library upgrade's sake, but make use of it if I get it right. But then the nitty-gritty starts with transitive dependencies. Okay.
Yeah, that's interesting. And to be honest, today everything mostly kind of works. I haven't. Like we have so much code where I work, and this is less of a headache than you'd think it would be, right? So something's working, right? It's not a massive problem. Whereas I remember in the early .NET Core days, we were hitting things with transitive dependencies and things not
binding redirects. Oh no!
Oh yeah, that's yes, binding redirects. That's the whole thing. Yeah. I don't want to hear
that. Okay. we edit that out as well. Yeah.
Things like bad memories. Awesome. Well, we're almost out of time actually, but I guess we've covered a lot of ground in this episode. And I remember at the beginning, Stuart, you said it's kind of like a smaller, like the features are not as big, but actually they sound super exciting, and it was actually quite a lot for me, at least.
There's no like big headline feature. That's the thing you want, right? But there were these little small things, but I find them really interesting. I like go in and have a look, and I love the way that you play with it and look at the lowered code and the compiled code and stuff.
Mhm.
Yeah, I find it interesting.
Yeah, absolutely. And thank you so much for coming on the show and showing us all those new features. It's always such a pleasure to have you. And yeah, it's been really awesome.
No, thank you for having me. Yeah, it's such a great stream. I love it. Yeah, thank you.
Oh, thank you so much. Speaking of, when is we next of our stream?
That is an excellent question. What is the answer? I
Well,
don't think we have an answer yet, which is why you should definitely take a minute and subscribe to our social media channels, so you're up to date with any upcoming streams and events, and yeah, just generally what we're up to. Also, if you have any questions or comments, you can always reach out to us. And I guess also YouTube is on there, so if you want to watch any previous episode, you can also head there if you missed us too much between the little break we're about to have.
We also, we'll take a bit of a holiday break. Also think about, well, we will do some smaller changes to the stream itself. Maybe also a new format that we kind of promised.
Potentially.
Also, we started 2 years ago,
Use
but
it.
have never. Well, started is the wrong word. We kind of thought about it, but never really did it.
Well, didn't we do it, but just not publish it?
Not quite published. Yeah, it didn't make the finish line quite. Yeah,
It didn't make the finish line. Yeah, there's loads of exciting new things coming up in the new year. So please, yeah, stay tuned. I'm really excited. And you should be too.
Then, yeah. Thank you again, Stuart, for joining. This is the end of the year. Alle Jahre wieder. We say in German. Reoccurring things that we look forward to. I'm already looking forward to .NET 10 and C# 14. And yeah, have great holidays and see you next week. We'll be back.